A disclaimer, this has nothing to do with any kind of opinion forming influence in terms of using or not using vaccines. This is purely for educational purposes of showing how the scientific process of hypothesis testing generally works. So I'm going to use the example of the COVID-19 data, which is a very hot topic, you can say, lately in the last couple of years. And let's say that one thinks that based on, everything that's been going on in the news and the media, that one can propose that the vaccines that are available, that they have a positive impact on reducing the number of cases of COVID that occur in a particular location, and furthermore that they reduce the death rate of a population in a particular area. So let's say one may think that, right, just based on the news that one gets, and one can, basically get some data that are, like I said, freely available on the internet. And I'll just show you very quickly how one can download and open the data, and with a couple of easy steps, see if there is evidence for such a claim. And if there is evidence for such a claim, how strong this evidence is, and how strong is the potential impact of let's say, getting vaccines in terms of reducing the chance of getting COVID and potentially dying from it. So back to our hypothesis, we thought that we propose, based on just based on what we've heard, that let's say getting vaccines reduces the chance of getting this disease and dying from it. So I got this data. This is an example from Germany. So obviously, you have to take it with a grain of salt. It can be different for different countries. So in case of Germany, the Robert Koch Institute is the institute that basically gathers these data, and they are, like I said, publicly available. So in this case, you can just see the website that I went to here to get these data, and you can basically, you can just click on different buttons here on the left to get the number of people per population in each region of Germany who basically got vaccinated. So for example, if I put my mouse over one region here, I get 60.93 vaccinations per 100 people, right? And if I go to a different region, it shows that it's in this region, it's 65 vaccinations per 100, and so on. And so obviously you can kind of just go to different regions and kind of see where more people per 100 have gotten the vaccine. And you can kind of have a rough idea where in Germany you have more vaccinations than in other parts. And you can do the same by clicking on, let's say, on how many cases of COVID per population have been registered in Germany and how many people have died from it. Again, you can get this map where, by hovering your mouse over different regions, you get the number of cases per 100,000 people population. And if you click on, deaths, then you'll have the same similar map. And then by hovering over different regions, you'll have the different number of deaths per 100,000 population of people who have died with this COVID. And so back to our hypothesis, we thought we need data on both, on the number of vaccines per 100,000 for different regions, and on the number of infections, and even more importantly, deaths. So basically all I've done was, so I've opened this website, and if you scroll to the bottom of it, there's an option to download data. So I just clicked on this download data, and it just downloads as a CSV file that you can open in Excel or in Excel. So, and if you open it in Excel, then you basically have these the data as you see on my screen here. You have the Landkreis, or basically a small sub-region. Then you have the Land, like the similar to a province. Then you have the number of cases in total. Not really interesting for us. Number of cases per 100,000. This is nice data. Then you have number of deaths in total. Not as interesting for us because, of course, just more population per region, you'll have more cases. And then interesting, you'll have deaths in total. That's also deaths per 100,000. So this is interesting for us because we want to see exactly if the number of vaccines correlates with, has an influence basically on the number of deaths per 100,000. So so all I did was basically downloaded this one file and opened it in Excel, where we have the cases per 100,000 and the deaths per 100,000. That I basically marked here in yellow. And then I did the same for the vaccination rate. So, and then I just basically arranged the columns by the Bundesland, or by the kind of like a province, right? So I just matched the number of cases per 100,000 for each province with the number of vaccines as in a different column. So then basically we have this simple Excel file, and what is then possible to do, which is very quickly done in Excel, you just basically, let's say you select just a couple of columns that you want to see if one factor has an effect on the other, and you can just click on to create a linear correlation between any two columns or between any two factors. So in this case, for us, we wanted to see if the vaccination rate, which is in this case the number of vaccines or full vaccines per 100 people in a particular location, and we want to see how that correlates with, let's say, the number of cases per 100,000 people in a particular location. So then we get the following correlation. So in this case, on the x-axis, we have the number of vaccines, right, per 100 people that were administered in a particular, let's say, province. And on the y-axis, we have the number of people who have gotten COVID in this particular region. And just by clicking on the dots in Excel, you can add a best fit line through it, and by basically clicking a couple of buttons on the menu here, one can get an idea of the potential influence of one factor, in this case the vaccination rate, on the rate of contacting this virus. So in this case, we see that there's a negative, there seems to be a negative relationship between the two factors. namely that the less percentage of population in a particular area or province that got the vaccination, the more cases of COVID per population were registered in that location. So, and the interesting thing here is the R squared value, which I am highlighting at the moment here. So this R value in this case, 0.6458, is a close approximation of the percentage of variation in terms of how many cases of COVID were registered in every location. So about 60% of that variation can be explained by the rate of vaccination in a particular area. So about 60% of the variation in the number of cases is explained by the vaccination rate. The real percentage will vary depending on the number of data one has, and basically this just goes into statistics a bit more in depth. Just for this example, I'll show you how one gets way more accurate R percentage. In this case, all one needs to do, Excel has this nice simple statistical feature that if you just click on data analysis, and in this case what we are doing is a regression, and basically our X factor, or the factor that we think is influencing another factor, is the column with the number of vaccinations, and our Y factor, or the dependent variable, basically how many people are getting COVID, is I'm selecting the different column here, and that's basically all that's required. And when you click OK, so then we get basically this result, and this has a more accurate R square value. So I'm highlighting it on the screen here. So like I said, it was close to, when one just does this regression line on this figure, right? One gets a value of 0.6458, and if one does this statistical regression test, then one gets a value of 0.614, which is a little bit different, like I said. But if for the purposes of quick estimations, if one has more than, let's say, 10 points on a graph relating two factors against each other, and one gets an R square of more than 0.6 or 0.7, then one can be fairly certain that the real R square, or the percent of variation that is explained via the X factor, is in fact that percentage is fairly high. And yeah, the other interesting basically statistical tidbit here is this p-value that we see, that I'm highlighting also here a little bit below. So in this case, 0.0009. So basically this is telling us that there's only a very, very minute chance, in fact, what is this? I'm not sure, 10 thousandths. So virtually way less than 1% chance that it's likely that one would get such a correlation between these two factors if there was in reality no influence of the X factor on the Y. So basically you can be fairly confident that the number in this case of vaccinations per population has a significant influence on the number of people who get COVID. And well, it's important to note also that although it's highly significant, the R square is about 60%, so 40%, so almost close to half of the variation we see in the number of people getting vaccines is not due to this factor of how many people actually get the vaccine. One can right away obviously think of many other factors, like what is the proportion of old and young people in a particular population, what are the contact rates are between people in a particular province. So all those likely also play a role. So if you had data on those, let's say the average number of, I don't know, contacts per person in a particular land, or the proportion of people over the age of, let's say, 60, one could also easily add this in a column. So, and then likewise, all one needs to do to see the effect of the vaccinations on the death rates of an area is one just changes the y column, or basically our dependent variable. So in this case, on the y-axis, I've just shifted the column that is represented, or the data that is represented on the y-axis, and we now have not the number of cases, but rather the number of deaths per 100,000. And again, we're seeing how that is correlated with the number of vaccines, or percentage of fully vaccinated people of a particular region. So again, we see a similar trend with similar R squared values, and that being that basically, the higher the percentage of vaccinated people in a particular area, the less deaths with COVID occurs in that area. And one can also explain that a little bit more. One can say that roughly a 20% decrease in the rate of vaccination causes the number of deaths to go up from around 50 to around 250. So that's around a 5-fold factor of increase in the number of deaths per 100,000. Yeah, so that's basically all I wanted to talk about with respect to basically gathering this type of data quickly on the internet, and seeing what the impact of a particular factor is on another, and how strong the evidence seems to be based on the data on whether a particular hypothesis may or may not be true. And just final little caveat. Of course, what we're seeing in this particular example is a correlation between two factors. And as one often hears, correlation does not mean causation. So just because lower vaccination is correlated with higher death rates, may not necessarily be the absolute main causal mechanism, right, behind this. All this is showing is that, statistically speaking, in areas where more vaccinations is done, we do have lower number of deaths and COVID cases per population. That's all it's showing. It's not telling us why. So the why is then obviously where the speculation comes in, and discussion and politics and so on. And what one does with this data, how one presents it, that's the next step of analyzing the data. Yeah, so that was it from me, and you can look forward to another episode, hopefully in the near future, where I will probably have a look at something sports related the next time. Thanks for listening. Bye.